Last class we were discussing about the design of a staircase, design of a dog-leg staircase. So as you see, we are having different types of staircase. Staircase is divided based on the geometrical, based on the shapes, based on the way they are spanned. On the different ways the staircase are uh, So here we are discussing about the design of dog-leg staircase. Okay, as you see right now, that is a design of a dog-leg staircase. So here you can see the stairs are going upward in one direction, and here we are having a landing slab. Okay, here we are having a landing slab. So after the landing tab, the person is taking a turn. Okay, the person is taking a 180-degree turn. Okay, so here see. From here you will be taking a 180-degree turn and you will be going in the opposite direction and you will reach your destination. Okay, so such a slab is called as dog-leg staircase. Okay, so here what are things that you have to design is that first of all, if you see in this figure, the whole slab, the slab is resting. See, this is a schematic view of the dog-leg staircase. Okay, so here you can see this is the steps. The step comprises of two portions. First one is the riser. This is the riser portion and this is the tread portion. Okay, riser portion and tread portion. And both this riser and tread portion is resting on the waist slab. So this portion is called as the waist slab. Can you see this two-lined portion? Okay, two-lined portion line. Okay, so the two-lined portion is called as the waist portion. Okay, so this waist slab you have to design. Okay, and here this is the landing slab. Okay, this is the landing slab. This is a schematic view. Okay, this is the full view of a dog-leg staircase. Okay, so here up to landing, the view is up to landing. This is a full view. Okay, this is the full view of a dog-leg staircase in the room. It's full height view. Okay, this is how you will be seeing a dog-leg staircase. So this you might have known because when you are a civil engineering drawing, you might have drawn in the building drawing. You might have drawn this type of stairs. Okay, so we are going to design such a staircase. Okay, so before designing, you need to understand all these basic parts. Now, let's go to the design portion. So the question is, so what is our question? The question is to design a dog-leg staircase. The question is to design a dog-leg staircase for a room of 3 into 6 meter dimension. Okay, 3 into 6 meter dimension. So write down the given data first. 3 into 6 meter dimension. That is the dimension of this room. Okay, floor to floor height. Okay, the floor to floor height of the room is 3.5 meters. Height of the room is 3.5 meters, and the building is a public building. Okay, this is not a residential building, so this is a public building, and also they have warned you there's a chance of overcrowding. Okay, now this stairs is supported on a walls of 230 mm thickness. And next, okay, that's only the details they have given. Next is they have provided about the concrete and the steel details. Concrete that you are using is of M20 grade, and the steel is having a grade of 450. So these are the available data. First on the available data, write down all the available data. Coming to the first step, that is proportioning. Okay, proportioning of various dimensions. Proportioning of various dimensions. Okay, this is the first and most important portion of a design of a staircase. Okay, so how do you proportion? So first of all, let me tell you the available dimension of the room is the available dimension of the room is 3 into 6 meters. 3 into 6 meters, so which means that this is 3 meters and this is 6 meters. Okay, all of you draw the figure with me, okay? I won't give an extra time to draw the figure. You have to draw the figure with me, okay? So 3 into 6, this is the dimension of this room. This room, you have to provide a staircase. Okay, for this room, you have to provide a staircase. The height of this room is 3.5 meters. Okay, so available width for the staircase. Okay, so we'll be arranging the staircase like this. Okay, so how will be arranging the staircase? Okay, so if you're starting from here, okay, if you're taking this as an entry point, here you will be having a landing. Okay, here you will be having a landing, and here you will be having the steps. Okay, the steps will be like this. Okay, the steps will be like this. Okay. So there will be a landing over here, and after the first stair, okay, this is how the first stairs are taken. Okay, first stair is taken from here, and there is another landing over here. From there, you will be taking another turn. Okay, so that you will reach on the top, or you will reach the destination. Okay. Okay. So this is how the picture of the stair is going to be. Now we have to dimension. That is, you have to decide how much should be the width of the stair, how much should be the width of the landing, how much the flight, how much should be going, all these things. Okay. So first of all, we can assume the available width of the staircase. So how much is the available width of the staircase? Write down the available width of the staircase. Available width of the staircase. See, this whole width is available to us, right? This is a 3 meter, okay? And this 3 meter width is available to us, okay? So through this 3 meters, you can decide, okay? So that is our room width. That room width is available for the staircase. So available width of the staircase is the width of the room, that is 3 meters. Okay, 3 meters. Okay, so since this is a dog-leg staircase, this is having 2 flights. Flight means how much? The arrangement of steps. The arrangement of steps in one set is called as a flight. Okay, so here it is having, so this is one flight and this is another flight. Okay, so this portion is called as a flight. Okay, so dog-leg portion you will be having 2 flights. That is, this is the first flight and this is the second flight. Okay, here portion when you are calling it as a flight. Okay, so assume, since it is a dog-leg staircase, you have to assume 2 flights. Assuming 2 flights. Assuming 2 flights. Okay. Okay. Next assumption, you have to assume a lot of values over here. Okay. First assumption you have already made is that it is having a 2 flight. Okay. So this is the first flight and this is another flight. Flight in the step arrange first landing first distance between the 2 landings taken as 1 flight. Okay, so here there is a 1 landing and this is another landing. Okay, so this portion is called as the portion between the 2 landing is taken as flight. Okay, so here 1 flight and this is another flight. Next, you have to assume the width of each flight. So you can assume this width of this step as 1.35 since it is a public building. Okay, width of this step, or you can say width of this flight as 1.35. we can assume this portion, okay? Assume this portion as 1.35. Since it is a public building, it will be ranging from 1 to 1.5 meter. That is a range. Okay, public building I don't know. Okay, so here you can assume this portion as a 1.35 meters. Let us assume here. Angle, the space between two flights. That means you can see a certain portion of space is there. Okay, one flight. This is a one flight. This portion is between these two portions. So here a flight here there is another flight. The portion between these two, how much it is? The space between this. That is the next you are going to calculate. So how much it will be? So this is 1.35 and this is also 1.35. Ready? E space. How much it is? Okay, stairs between the two flights there will be a particular space. And the flight in the space is down. So how much is that space? So the spacing between flights. The spacing between two flights is equal to total distance of 3 minus 2 into 1.35. That is E distance calculate E distance. How much is this distance? That is you have to calculate. So tell me how much it is. Okay. This distance, how much it is? That is you have to calculate. So total distance is 3. So this is 1.35 and assume 0. This is also 1.35. Okay. So public building, you can assume the value between 1 to 1.5 meters. So here we have taken 1.35 as the width of the flight. Okay. So 3 minus 2 into 1.35. How much you are getting? 0.3. Okay, so this distance we can mark it as 0.3. Mark it as 0.3. Okay. Next, coming to the floor to floor height. Floor to floor height is already given, that is floor to floor height is already given, that is 3.5 meters. Height of the room, that is taken as height of the room or a floor to floor height is 3.5 meters. Okay, so what will be the height of one flight? What is flight in the height? Okay, the height of one flight, how much it will be? 3.5 divided by, write down, height of one flight. Height of one flight is equal to 3.5 divided by 2, that is 1.75. Good, 1.75. Okay, that is year flight in the height, total height of the building. Okay, for example, if I am taking this, okay, if I am taking this, okay, height of this building over here, don't take this dimension. Okay, height of this building is 3.5 meters. Okay, height of this building is 3.5 meters. So this is taken as one flight. Okay, so this is one flight. Then or flight is one flight. This is taken as one flight. And this is taken as another flight. Okay, this is taken as another flight. Don't take this dimension. Okay, so total height of this building is 3.5 meters. What will be the height of each flight? So how much it will be? 3.5 divided by 2. So how much you will get? 3.5 divided by 2 means 1.75. That means one flight it will be having a dimension of 1.75 1.75 meters. 1.75 meters. Okay. Now next is you have to assume the height of the. Now next is you have to calculate number of steps in one flight. Okay. Number of steps, to be more specific, number of risers. അതായത് എത്ര number of risers ഉള്ളത്. This is the riser. Okay. This is called as the risers. Number of riser in one flight. Okay. So riser value you have to assume. Okay. So generally riser is taken as 150 mm. Okay. So generally riser is taken as 150 mm. So how much it is? Generally riser is taken as 150 mm anengil number of risers. How much is the number of riser? Write down number of risers. Number of risers in one flight. Okay, number of risers in one flight is equal to 170 divided by 150. Okay, so 150 is the general assumption. Okay, 150 is the riser you have to assume. 150 mm. So how much it will be? 11.66. That is approximately 12 risers. Okay, number of riser. Riser this is the riser. Okay, so number of risers at a flight. This is taken as one flight. Okay, this is one flight. Here at a flight, number of risers. How much it should be? They are telling there should be 12 number of risers. Okay, next is number of treads. So number of treads, the flat portion, so this horizontal portion is taken as treads. Extra number of treads and so treads is taken as number of riser minus 1. Number of treads is equal to number of riser minus 1. That is 12 minus 1. That is 11 number of risers. Okay, 12 minus 1. That is 11 number of risers. Okay. Okay, so we can say that in our numbers 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 number of risers on the okay, 12 number of risers and numbers of treads has occurred. Okay. Okay, okay. Next is total distance of. So next is you have to calculate total going. Total going. So going means this is taken as the going. That is the distance. In this figure, if you see, this is the going distance. This distance from this distance. This is taken as going. This distance, I am calling it as going. Steps. To be more specific, we can say okay, so this is taken as the going. This distance, this is called as the going. This distance taken as going. So how will you calculate going? Okay, so going in a calculate here. So these are the tread portion. So extra numbers of treads the portion. Okay, this width, number of treads. So we are having 11 number of treads. 11 number of struts, and the width of the struts. What is the width of the struts? We don't know. So we'll assume it as 300 mm. Okay. So you will assume the width as 300 mm. So write down. Assume the width of the truss as 300 mm, and total going is equal to. Okay. And total going is equal to 300 into 11. So that is 3300 mm. Okay, this one. This is called as a going. Okay, so here this is a landing slab. Okay, landing, and this is also landing. Okay, so width of the strut is 300 mm. Okay, 300. Okay, ഇതുപോലത്തെ 11 എന്നാണ് നമുക്കുള്ളത്. Okay, the horizontal distance of this width of the flight is taken as 1 going. So that is 330. Okay. Now next is you have to calculate the width of the landing. Next is we have to calculate width of the landing. So how will you calculate width of the landing? So draw this figure, okay? Draw this figure along with me. So this distance is taken as 6 meters. This is 3 meters. Okay. So here there is one landing portion. Here there is another landing portion. In between, this is the steps. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15. Okay. So this is the landing portion. So this width is 0.3 meters. Width the 1.35. This is also 1.35. This is the landing portion. So how will you calculate the landing portion? The landing portion is equal to total width of 6 meters. 6 meters minus, how much is this distance? How much is this distance? This distance is, this is total going distance. Going, this is the total going. So going is equal to 3300 mm, which means 3.3 meters. Okay, so you have to distribute it on both two sides, divided by 2. So how much you will get? 6 minus. Okay, that is, ഇവിടെ ഒരു landing ഉണ്ട്. Here there is one landing. Here is also there another landing. Okay, so total 6 meter minus going distance we have calculated right now. Going distance is 3.3 meters. Okay, 3.3 meters we have calculated. Okay, so 3.3 minus both the portion divided by 2. Here also one landing, here also one landing. So that will be 1.35 meters. So that will be 1.35 meters. Okay, so we can say that this is 1.35, one landing. Width of the landing is 1.35 over here. Dividing 1.35 width of the landing. Okay, so width of the landing is 1.35. 1.35. Here also 1.35. Don't get confused. Okay. So So now all the dimensions are clear to us, right? Width of this width of this is width of the thread is 300 mm. Okay, width of the thread is each thread is having a width of 300 mm. അങ്ങനെ എത്ര ഉണ്ട്? 11 ഉണ്ട് സൈഡിൽ. Side there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 11 number of threads in there. Each is having a width of 300 mm. The spacing between two flights is 0.3. Okay, so landing width is 1.35. All the dimensions are now known to us. Mark all the dimensions. Okay, so this is the first thing that you have to do. Mark all the dimensions. Okay. Draw this figure. Okay. Next, they have mentioned in the question that the stairs are resting on a wall of 230 mm thickness, which means that here there is a wall of 230 mm. Okay. Now here there is a wall of 230 mm. Here also 230 mm. So this dimension of this wall is 230 mm. Okay, so this also you have to show. Okay, so by this the figure is complete. Okay, now moving on to the second step, step number 2. That is, now that we have proposed all the dimensions, all the dimensions are clear to us. Next thing is we can start our design. Second step, that is the design of a staircase. The second step is design of a staircase. Step number 2, design of a staircase. Design of a staircase. So first now you have to calculate the effective span. Okay, first one is effective span, that is center to center distance between the wall. Effective span of the flight. Effective span of the flight. Okay, effective span of the flight, that is center to center distance between the walls. That is center to center distance between the walls. So how much is center to center distance? To center distance, you can see here this is a 6 meter. 6 meter the wall. So 6 plus 0.23 by 2 also 0.23 by 2. So that is 6.23 meters. So that is center of this wall to center of this wall is 6.23 meters. The wall thickness is known to us. It is given in the question, that is 230 mm. Okay, so wall thickness is 230 mm. Okay, so 6 plus 230 by 2. After the side line 230 by 2, so we will get 6.23 meters. Okay, so center to center distance flight is 6.23 meters. Okay, next step, that is thickness of the waist slab. Thickness of the, calculate. Did you write? Shall I write this one? Okay, next is thickness of the waist slab. So before that you have to understand what is a waist slab. Okay, so in this figure, this is a waist slab. Okay, so this, the slab on which the steps are resting is taken as the waist slab. Okay, so this is called as, this portion is called as the waist slab. This portion is called as the waist slab. Okay, so next is you have to design this waist slab. So first of all you have to calculate the thickness of this waist slab. How much is the thickness of this waist slab? Okay, how much is the thickness of this waist slab? You have to calculate. So that is taken as L by 20 of the span width. That is taken as L by 20 of the span width. So it is taken as L by 20 of the width. Okay, so L is how much? L is taken as effective span. So that is 6.23 divided by 20. Okay, so how much is the width? How much is the width? Class now. A second, a second. Okay, Okay, okay. We can continue now. ഞാൻ വരാം സാറേ, ഇപ്പൊ 5 മിനിറ്റ് ഞാൻ ഇപ്പൊ ക്ലാസ്സിലേക്ക് വരാം. 5 മിനിറ്റ് ക്ലാസ്. ഞാൻ വരാം. Okay, we can continue now. 6.3, that is our value, 6.23 into width. Okay, so width, that is we are taking slab. Okay, so as I had told, for the slab, always we are taking 1 meter width. Okay, slab ആണ്. So slab always നമ്മൾ എടുക്കുന്ന എന്താണ് 1 meter. So slab always we have it taking by always designing a slab, we have to take 1 meter width. Okay, width 1 meter ആയിട്ട് assume ചെയ്തിട്ടാണ് നമ്മൾ എല്ലാ സ്ലാബും ഡിസൈൻ ചെയ്യുന്നത്. Whether it is a 2-way slab, whether it is a 1-way slab, whether it is a raised slab for the steps. Okay, so width of the slab is taken as 1 meter. Okay, 6.23 divided by 20 into 1. So how much you will get? Tell me the value first. 0.33 something you will get, right? Okay, so 0.33 meters, 0.311 meters. Okay, so taking it into 0.3315, taking into mm. Okay, taking into mm, that is equal to 311.5 mm. So that is 311.5 mm. Okay, so we can assume depth. Okay, so we can take the depth of the waste slab as, okay, depth of the waste slab, we can assume this 311, we can assume it to something like 320, including that now this is the effective span. So this is the effective depth, right? So in that we need to add the cover, and also you need to take the diameter of the steel bars. Okay, on an average you can take it as 325 mm. Okay, you can assume, okay, you can round up the depth of the waste slab as d is equal to 325 mm. D is equal to 325 mm. Okay, now next, load calculations. Coming to the next step, that is load calculation. Okay, so ഇത് മനസ്സിലായില്ലേ? This is effective depth. ഇനി effective depthലേക്ക് cover has to come, and also the diameter of the bar has to come. Okay, so എല്ലാം കൂടെ കൂട്ടിയിട്ട് you can make it on an average, അല്ലെങ്കിൽ on a summation you can assume a depth of 325. Next, step number 3, that is load calculation. Step number 3, that is load calculation. Okay, so first of all you have to calculate the weight of the slab. Weight of the waste slab. So weight of the waste slab, for to calculate you are having an equation, that is d into 1 plus r square divided by t square into unit weight of RCC, that is 25. Okay, unit weight of RCC, that is 25. Okay, so here d indicates overall depth of the slab, that is 0.325 meters into, okay, so since this is an empirical formula, you have to substitute this r in mm, so that is 150 divided by 300 into 25 into 25. So how much you're getting waste? Okay, now I think you can post your name to mark the attendance now. All of you please post your name to mark the attendance. You can continue in the next class.